So, welcome everybody to our regular Wednesday meeting. It is May 21st. And before we get started, I'm going to read the disclaimer. Please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. And with that out of the way, so tonight's agenda, we actually have two presentations by Peter. One of them is the Ltspice and ChatGPT, calculating the bandwidth using the measure whatever in Ltspice, and then an update on FDIMn North. So, Peter, ready to rock? You're muted.
Oh yeah. The second one is not a presentation. That'll be coming later on FDIMn North. It's just a little bit of a little bit of a high level update.
Okay.
Okay. We can see that?
Yep.
Okay, Ltspice and ChatGPT and how to calculate the bandwidth using the dot measure statement. I will say right off the start that I think I know 99% or 95% of how it works, but there's still a couple little bit of gray areas in it. So hopefully nobody picks up on the gray areas. So the question is, using the dot measure directive, how would you calculate the bandwidth of the amplifier output? And of course, why would I want to do this? Because we've all been using the cursors. Well, not all of us, but for the most part, cursors are used quite a lot. But have you ever tried to use them to get a really precise measurement? Sometimes it's a little bit tricky to actually place the cursor in accurately where it really needs to be. And even worse yet is when you do multiple simulations due to changing a capacitor, resistor, or transistor, whatever the case may be, to see how your circuit behaves with these changes. And then you got to go start over again with your cursors and start placing them again, read them, and all that kind of good stuff. So it's much better to spend some time to try and figure out how to use some of the directives. And then, of course, how difficult could this be? I've already given some thought. And, if need be, there's books, YouTube, internet, groups.io, ChatGPT even to help. And, well, away we went. So this is the circuit that I started with, or at least got me going with it, mainly because the op amps, and I was changing the different values of these resistors to, maybe have the gain higher at the front end instead of the back end and switch them around and all these kinds of things. So pretty soon it got really cumbersome to be using cursors, and it was becoming a real pain to do that. Ignore the statements up on the upper right. That has nothing to do with what we're going to talk about tonight. Actually, even the circuit has nothing to do with it. It was just, this is the bit of the genesis of it all. So I had a bit of an idea in mind of where to start, and away I went. And I kept trying different things and changing. If you actually spend some time and going through some of these directives, the last statement is pretty much the same, but everything above them is different. So these things change as they don't work. But I was always ending up with this at the bottom. And eventually it got to the point, probably somewhere around here, where I gave up with help screens and books and things like that, and a bit of the internet searches. And I probably started in around there somewhere, I can't remember now, using the ChatGPT to see how that would help me out with this exercise. So here is a I'll warn you now, I'm not going to read this. Even if you ask me to read all this to you, I don't think I will. Anyway, this is pretty much the complete conversation. Maybe that's not the right word, but with ChatGPT on when I was trying to sort out what was going on. So just a couple of little points here. I said, is there anything wrong with this Ltspice directive? And I gave the directive, and ChatGPT came back and said, yes, there's a couple of issues with the directive. Undefined peak value, blah, blah, blah. And on it go. You need to either calculate the peak value, magnitude, and on and on and on it went. And, and then I would try these. And then I would say, well, the second line fails. And ChatGPT came back and said, you're right. The second line can fail because of whatever. And then it'd give ideas and on and on and go. By now, you're really, I don't want to say sucked into this whole thing, but it's almost like you got to see it to the bitter end. And then finally got to the point where everything was working. And then except for the one measurement, lower 3 dB failed. And ChatGPT says the error occurs because Ltspice cannot directly use the result from a previous measure statement. So anyway, on and on and on and on it goes until finally, down at the bottom, I just said, winner, winner, chicken dinner. And ChatGPT came back and said, glad to hear it. Enjoy that bandwidth measurement. No 3 dB hunting required. And it sent the little smiley face and then said, if you have any more challenges, I'm here to help. Thank you. It was right around now that I thought maybe I should give him a name, Bob or John or something like that. That's the kind of back and forth they end up having with ChatGPT over this stuff. So here I decided to just take down everything that I tried, and I just shrunk it up just to give you a bit of an idea of this rabbit hole I went down that I thought would be just a fairly simple thing to do. And I think there's at least 50 different directives in there that I tried in order to calculate something what I thought wouldn't be so difficult. I will say, though, if you're looking at the bottom line to get after what I wanted, you'd have to say this is really a convoluted way to go and maybe a colossal waste of time, I suppose, although I did get the answer eventually. But there's other rabbit holes that come out of all this kind of stuff too. So, and of course, this group is quite famous for going off in tangents. So, upper right-hand corner, forget whatever you see in blue there, just in black, except for the dot and H statement. Forget that one. So we have dot measure, gain, max, mag, V out. And then the next line, measure, value 3 dB, parameter, gain divided by the square root of 2. And then measure bandwidth when mag V output equals value 3 dB. That seemed pretty simple, doesn't it, compared to what I was going through? And there's the results of those 3 lines, and the gain's showing 27.9292 dB. And if you take a look at the green there, you can see that the line is just above the 27.9 dB mark, and it's calculating the 3 dB point down at 24.9. And if you kind of take your cursor down there, you would see that it would be just around that 24.9. And the frequency that it found it at was at 28.7 megahertz. So I thought, well, that's pretty good. So how did I get there? Was it the Ltspice help and educational examples that Spice had? Was it ChatGPT that gave me the answer? Was it some book I finally found that gave it to me, or was it even YouTube? So Ken, you can see everybody's hands as they hold up there. Keep track of it for me, please. So hold up your fingers on what you think the answer is. I'll give you a minute. Time's up. Okay, who picked number 4? Anyway, that's where the answer finally came from. I decided to use YouTube. And if you Google on YouTube, automating calculations using the dot measure in Ltspice, you will see the video. So I thought just let's break down the statements and just see what they're doing. So the first one is dot measure gain max mag V output. And this directive calculates the maximum gain at the output node. The word gain, that's the name you assign to the measurement. So Ltspice will store the number that it comes up with, the results of the simulation under that name for later use. Max specifies that Spice should look for the maximum value of the following expression, which is mag V output. And this is the magnitude or the absolute value of the voltage at the output node. So gain will store the maximum magnitude of the output voltage across the entire simulation frequency range. The next statement is dot measure value 3 dB parameter gain divided by the square root of 2. And now this is another measurement, but this is type of a parameter, which means it computes a parameter based on other measurements. Value 3 dB is the name assigned to this calculated parameter, and which will be approximately the voltage value at which the output is reduced by 3 dB from its peak. And the parameter gain divided by the square root of 2, that specifies the parameter equal to the gain divided by square root of 2 in decibels, a 3 dB drop, reducing the amplitude to approximately 70% of the peak value, which is mathematically the gain divided by square root of 2. And that will set the value 3 dB to the level of the voltage magnitude that corresponds to the 3 dB reduction from the maximum. Okay, the third line, dot measure bandwidth, BW, bandwidth when the mag output equals that value 3 dB. And that'll find it at the frequency at which the magnitude of the voltage falls to the value of 3 dB. There is a bit of a gray point there. I guess maybe it might come up in a minute or two, or at least on the last slide it will. BW is the name for this measurement result that'll hold the frequency at the 3 dB point. When instructs Ltspice to report the point, the frequency or the time, depending on your simulation, at which the following condition is true, and that is when mag V output equals the value 3 dB. And that tells Ltspice to look for the frequency at which the magnitude of V out equals the value 3 dB. Thus, BW, bandwidth, will store the frequency at which the gain is down 3 dB from its peak value, indicating the bandwidth of the circuit. Hopefully that's all relatively clear. So, putting it all together, these set of measurements typically used to automate, calculate the bandwidth of a circuit, like an amplifier or a filter. I'm going to just say filter, maybe a low pass, high pass, that kind of thing, but I'm not, we'll come back to a band pass. So one, we measure the peak output gain. We calculate the voltage at the minus 3 dB point, and then we find the frequency of where this 3 dB point value occurs. And again, there's a little bit of not quite right there. I didn't pick up on it when I first put this together, but I certainly did a few days ago. Okay, so improvements, and this is, okay, choose the starting frequency near the peak. So once you start doing your simulations and you see in your graph, really your starting frequency should be relatively close to the peak. And the reason I say that is if you set the peak if you set the starting frequency way down to say where like your amplifier rolls off at the front end, it can change your results a little bit. I need to do some more simulations on that just to get a better handle on what's going on with that. But it's not too difficult to to actually see what's going on and actually pick an appropriate frequency. Setting your maximum frequency setting is not critical, mainly because it's just going to calculate the minus 3 dB point from its max, and that's not an issue. It was only the front end that I kind of saw a little bit of something going on. And that's where I made a point there. Need to run additional simulations, in particular the filter such as a bandpass filter, because it's that kind of waveform profile that I saw that I need to understand just a little bit more. Now here I put down to calculate the actual bandwidth, and that's why I was saying a couple slides back to be a little bit of a gray area. When I first did these calculations, your bandwidth was right there, and I didn't quite pick up on it at the beginning. But what's happening? It's not picking up the very front end first. The results is not actually saying with the bandwidth. It's just telling you where the 3 dB point is down, and it just so happens to be the bandwidth. In other words, if you start your simulation at 1 megahertz and you finish it off at 30 megahertz, and it calculates, okay, your peak is around the 1 megahertz or 2 megahertz in that kind of area, and the 3 dB point is down around 28, you see your number up there, 28, there's your bandwidth. That's correct. Well, not really. So that's why I need to do a little bit more work. And I don't think I'm going to say, I don't think it'd be too much work or effort to do it, but look what happened to me when I said that before. But I think if I calculate the peak at the front end there and then be able to do a little bit of math, and maybe I can come up with a little bit better directive to calculate the actual bandwidth. So that's why I say I need to maybe take a look at a bandpass filter and work on this these set of directives and get it to work on that one. And that's it. I hope that's relatively clear.
Hang on a second here. We got who's got the hand? I can't even see who's there. We got Charlie.
Yes, it's me with my hand up, trying to kind of make Peter's life miserable. Yeah.
I have to say, I go over these things, just before these presentations, because I know there's a couple of guys in here that are going to ask something that's going to catch me. So I go over these things, and then when I go over it, I discover, but it's too late to bail. Go ahead, Charlie.
So the bandwidth should be from where you're down 3 dB at the beginning to where you're down 3 dB at the end, right? And that's in terms of power. I think this is a voltage measurement, right? Shouldn't you be using 6 dB down?
That was one of the things that I thought about a couple of days ago or yesterday when I was doing this, and I thought, I wonder. But the numbers seemed to work, so I decided to ignore it for the time being. Maybe I shouldn't have, but at the time I didn't have time to explore it that little bit further. But yes, Charlie, I thought about that yesterday or the day before, but it was something in the end that I picked up and I went with it, and the numbers that seemed to result from a simulation agreed. So I didn't question it until, a couple of days ago. But you're right. I need to look into that a little bit more.
Dave.
Oh, good. His mic is broken.
I have to find the unmute button.
Mute him, Ken.
Peter.
Yeah.
Peter, could you go back to the actual simulation where you've got the dot measure statement, the Ltspice?
What, this one here?
Yeah, because, isn't there an AC statement missing in that?
Well, if you go up here, where is it? You can see here where I did start to mess around a little bit with AC stuff on these ones here. And over here, I was playing with the AC stuff as well. And I guess what happens is when you try these things, and you can't get it to work, and then you start looking at different resources, you end up with something like this. And then when it's spat out, 28 megahertz, and you kind of look, I'm down around 1 megahertz here at the peak, and up there it's it's working great. And I didn't tune in at the time that there needs to be a little bit more to it. So maybe you're right, Dave. Maybe there's something to change with this that kind of works, then maybe start changing around here to put the AC number into there. I'll make note of that to try that.
Can I just share my screen? Let me just share my screen here.
Let me just unshare here, Dave, as soon as I can find it.
Okay, can you see my screen here?
Yeah.
Okay, this is the Ltspice wiki for the measure statement. If you just Google Ltspice wiki measure, you come up with this the measure. This is so if you come down to where it talks about, see the statement, general syntax is measure, and then you have to specify AC, transient noise, DC operating point based on what you're running, right? And if you come down to the examples here, they have exactly the example you're looking for, which is right there. And you see it's measure AC, and that's just a variable name, temp. And you're saying measure what the maximum voltage is. Then it says measure BW, as you said, that's just a holder, just a variable. You could call that shift.
Oh, that's
it doesn't
right.
matter. You could call it.
No, I
You
realize.
could call it right. And then here's the what you need to go and run. It says how to run it. But notice they both have the AC.
You're right. And
in them.
Sorry. Go ahead.
No, that's it.
Oh, okay. No, and Dave, that's the way I went for it, because that's like that. I think that screen's actually in the help Ltspice help file as well, and that's where I started off and went down. And like I was showing you a minute ago, I started off down that path, and when I couldn't get things to work properly, I ventured off, and I guess I kind of forgot about that AC stuff. But you've reminded me.
Yeah, I'm surprised it even worked. You didn't get an error message.
Well, you know, when I watched that video and it worked, I thought, okay, I'll leverage it and try it. And sure enough, it worked. Now, it worked in this situation, but as I pointed out earlier, there's a couple of flaws with it. Well, now there's more than a couple of flaws. Thank you, guys. So I need to work on that. But anyway, it's a start. It's like a lot of the stuff we do here. We start with it, and then it doesn't work quite right, but there's some knowledgeable people here to set us straight.
Anybody else? There's still one hand up. I can't see who it is.
It's Charlie.
It's mine, and I'm not sure how to get it to go back down again. Somebody got rid of it for me. Thank you.
Anybody else?
Just last call, Peter, is really, this has to be like a bandpass filter that you do this on.
I'm sorry, say that again, Charlie.
I said this really has to be done on something like a bandpass filter. Like you've got a low pass is what you're trying to measure this on, and I'm not sure how you can do bandwidth on something like that unless you start off at DC, not at the kind of 2 meg you're talking about.
In this case, the number worked because I'm spanning from 1 to 30 megahertz, so the peak is at the 1 megahertz, and so it calculates it out great. It's only after the fact that I started to think about, well, wait a minute. What if you're interested in the lower frequencies? And now in this case, this amplifier doesn't roll off at the front end until you're down around, I can't remember, 50 kilohertz or, these type of things. So if you set your simulation right way back there, then your bandwidth will start to show a little bit more like in the 31 megahertz range, which may be correct, but knowing a little bit more about what I've got there and what I'm doing, it can't be quite 100% correct. It just may be coincidence. I don't know. That's when I said maybe I need to experiment a little bit more with a bandpass filter that has a bandwidth of I don't know, 100 kilohertz or whatever, something that's shorter. You can see it and then see how it behaves, and then it might be easier to get it to work correctly like that, and then it will work under any situation you throw at it. At least that's the way I'm thinking at the moment.
Go ahead, Kevin.
Hey, Peter. Something more basic, because I've actually got a bandpass filter up here, and I'm just trying to make this kind of do stuff. How do you get that graph up there of the measure results? Or a real basic question, because I don't know Ltspice very well.
You mean the graph that I showed, the roll off,
Yeah.
When you click on the output of your circuit with your probe, in your plot screen, it'll show that graph if you're using the appropriate commands, of course, they're using the analysis.
I get the output showing the bandpass, but it doesn't have any of the measurement calculations on it.
That's because you probably haven't put any dot measure statements in there.
I have a couple, and it's finding the max.
Okay.
And then I'm trying to find the minus 3 dB value.
The other thing I did too is when I went to the Spice log, I copied the information and then I pasted it in a text box onto the plot screen.
Oh, okay. All right.
Actually, I'm
trying to play along here.
As that brings up a point, I I don't use this very. Phil V3HST saw me doing a couple of years ago a ton of spice simulations that were generating results like like that in the air log, and he wrote me a Python script to basically half the information that was in the log I wasn't interested in, so he wrote a script for me, a Python script that would read the air log and only display the information that I wanted. The other, which was nice, and the other thing that was nice about it was, as long as you got two screens to use, because you put his Python program on the other screen. When you're using your Spice log, you got to close it and open it up after every simulation that you do. With Phil's program, you can leave it open all the time, and as soon as you run your simulation, that you click on the thing and refresh, and it's there. You don't have to open up and close the air log each time. So one of these days, I'll demonstrate that one.
Are you talking the Spice output log?
Yes.
Is that the? Oh, okay. All right. Yeah.
Used to be called the air log with early versions, and after several years, it kind of sticks in your mind. But in the last couple of versions of Ltspice, it's called Spice log or whatever it was you just said.
Okay. Yeah. All right. Okay.
All right. Go ahead, Michael.
Yeah, I was listening to what you're saying, Peter, and I have right here. I happen to have the LBS 40 meter bandpass filter. I guess you could simulate that, and then try these measure calculations with that.
Mm-hmm.
So and you could compare it with what actually you've got, what actually you measure with the assay, right?
Yeah, you could. The whole key of the exercise really isn't so much you're not thinking so much the accuracy of the well, no, that's not incorrect. You're trying to make the measurements or the statements reflect what the Spice is telling you, right?
Yeah.
Or is showing you whether it compares to the real world or not. Of course, that's another story. But we have now with some of the simulations, it's pretty close, and in some cases bang on, and on some cases not so much. But for the most part, it's pretty good. So the whole key is to kind of develop a series of or a bunch of statements that would negate the use of the cursors.
Yeah. Okay. Thanks. Yeah.
It's really nice when you're working on a circuit of some complexity, and you're making a lot of measurements. It's you're likely to be interested in more than just one or two measurements. So if you can simplify things by putting a lot of these measurements, dot measurements, statements, and whatever in there, and have it spit out in your air log or your Spice log, the data is right there. You don't have to, do a simulation, do your cursors back and forth, and and then make the notes yourself. You can do the copy paste and all that kind of stuff, and it's much easier but quick. And not only that, it's more accurate. As I mentioned earlier on, placing your cursors is not necessarily an accurate way. You may not be able to put it on the exact spot that you need to put it on. Whereas, when you're putting these measure statements in there, it's calculating the actual peaks and valleys, whatever it is that you're asking it to do.
Mm-hmm. Sounds good. Yeah. So this you said it was Phil that produced this Python thing.
Yeah.
Is that something that's relatively easy to use that I could try, say, without any knowledge of Python?
Yes, I just have to. I haven't used it in a while, so I have to refresh my memory on how to use this program. I know you got to use two screens for sure to make it truly useful. And like I say, it's really good to pull out the information you want and ignore all the stuff that you don't, all the crap that's in there that you don't want.
Mm-hmm.
And the other nice thing is you don't have to open and close the log. You just keep it closed and just run your simulations, look over at the script, and the info you want is there.
Mm-hmm.
Yeah. Anyway, I'll get around to demo at one of these meetings.
Okay, thanks.
Go ahead, Dave.
Yeah, Michael, are you familiar with Excel?
Yep. Well, so sort of know Excel, some of it.
Well, you could open that log file in Excel, and you could just create a bunch of macros to just, I've done that where you pull it into Excel and you just create a bunch of, not macros, you cell formulas, which split the line up. You search and you parse the string and you just write little things in the cell, and you could do that to extract the values. I've done that in the past.
Oh, it's an interesting idea. Something to try. Yeah.
There are lots of ways to skin the cat here.
Yeah.
I was just lucky that somebody wrote a script for me.
Okay, anybody else? Questions, comments? Okay, very good, Peter. Thank you.
Okay.
So are you going to just do a quick update?
Yeah, I'll just do a quick little overview of what we did because it's still fresh in our mind. And but a much larger presentation will be forthcoming. I'm not sure exactly when the person that's been tasked with it will be ready for it. But there is one that'll be coming up. There's a lot more detail. I'm just going to give a very quick overview. Does that mean you want me to start now?
Sure.
Okay. All right. So as I guess most of you know now that we all decided not to attend 4 days in May South this year because of the situation down in the States. And that was quite disappointing because it is something that we all thoroughly enjoy. Maybe not the drive itself, but certainly when we get there. And we've met some nice people down there and had a really good time and look forward to joining them again every year. So this year we decided not to. And then, of course, that's kind of disappointing in one way. And then we thought, you know what? Since we've all earmarked those 4 days down, and so why don't we try and figure out, maybe get together and do something, here in Canada. Well, it just so happens Smith Falls had a Hamfest going on that Saturday, which lined up with our week. So we thought, right, let's do that. Let's get an Airbnb for the whole 4 days. You're funny, Eric. Ask Dave if it's a real hoot. I digress. Anyway, I lost my train of thought. Where was I, Ken?
Airbnb.
Oh, the Airbnb. Thank you. Yeah. So we got an Airbnb, and we changed our in-person ticket, if you will, to can we just go for the online or the Zoom session instead? So we changed that over, and away we went. So Wednesday we get up there, and Dave and I got there a bit early, but we just sat around by the Rideau Canal and just enjoying the nice sunny day. And then we went over a little bit early to the B&B and to see what it was like. And I guess I don't want to say we were blown away, but boy, it was a nice place. I would go back there in a drop of a hat. We unloaded all our gear and, we had some 3D printers and test gear galore and some projects that we were going to be working on. So we offloaded all that stuff, and then we relaxed. Thursday was the full day of the seminars at 4 days in May. So we watched all those, and then of course into the evening it wasn't long before you start talking, our projects and things like that. Friday was what we call our geek day, and we spent the entire day sorting out the probe issues, or like what was wrong with my probe, and trying to figure out the behavior of it. Dave spent some time 3D printing and with Charlie and designing a support case for the motherboard for the backplane project. So that was pretty much a full day effort there. And that was interesting to see as well. We also took a look at Eric was also doing a little bit of 3D printing as well. I think he wanted to do some gambling that night, so he 3D printed up a bunch of funny looking dice that I did try a few times to see if they were loaded, but they seemed okay. But anyway, we didn't get around to that. But we did look with Eric some Arduino programming of an OLED, and he started to get into that. Saturday, of course, we went to the Hamfest, and then we went off to the FDIMn bunker. And then that Saturday night, we had a very, very intense teaching session for someone regarding this Arduino programming and how to troubleshoot programming errors and making things work. So that was a fun evening, and we were still friends on Sunday morning, so we went to breakfast together, and then we drove home. Anyway, that's the high overview. I don't know if it whets the appetite for the pictures to come later, but yeah, it was a very, very, very good trip. Very, very comfortable house, 5-bedroom home, big, large, nice pool table. Didn't have any funky curves or twists in it, and yeah. I think we all had a good time there.
How was the weather?
The weather was great. It did rain a little bit on the Saturday, but when we came back from the FDIMn bunker, we were able to sit outside for a little bit, and then it started to rain. But by the time it started to rain, it was a non-issue. Yeah, non-issue. Oh, it rained. It rained even throughout Saturday, but again, it wasn't that heavy. We parked the cars. Were parked a little bit away and had a little bit of a walk, but it wasn't an issue. And when we were at the house, there was lots of time to sit out. They had a very comfortable gazebo to sit in, if you so chose to. But we put the chairs outside on the deck and sat there and enjoyed the scenery. It overlooks the Rideau Canal from afar, and if you're familiar with Smith Falls, it overlooks the curling rink.
Cool. The Hamfest was inside or outside?
Inside, but there was one person who was outside. They only had one tailgater, and it happened to be one of my ham buddies here in Kingston. He set up a tent outside, and he sold Dave a scanner. So interesting. Yeah.
Go ahead, Dave.
By the way, Peter, that floppy drive doesn't work. Tell your buddy I'm going to have to strangle him. Sorry.
What do you mean it doesn't work? Charlie said it would work.
It doesn't work. It works like my PC sees it, but when I go and I insert a...
Did you check out
disk?
Into
it, notice the floppy too. Look at that. What's the floppy? DOS. Ooh, real man software. DOS. What version? 5. Man, real back in the day when software was software. Look, I plug it in, and it does nothing. Isn't it supposed to go in more and drop down because it's got to peel back this thing here?
It's got to peel back. Should magnetically pull it in once you've like you need it plugged into the computer. It needs power, right?
Yeah. Oh yeah, it's plugged in into the computer. It goes in, nothing spins, and the disk just sits there.
Interesting.
Huh.
So I would think the disk has to go in all the way, and you push the button here. It's got a little push button. You push that button to eject the disks out. Remember way back when? That's the way the floppies were. You would take it, stick it in, it would get eaten, right? And then you push a button and it spits it back out, right?
I'm not sure I want to get in between dusty, smelly old hams on fighting over a floppy disk.
If you really need to read that disk, Dave, I'll loan you mine. Mine still works.
No,
at least it did last time I plugged it in, which was, I don't know, probably 5 years ago.
It's okay. I'm just trying to get Peter riled up.
Oh, I'm not.
So Peter, you got to go back to him and tell him Dave's unhappy. He's coming out to Kingston and he's going to pay you a visit. And he's going to bring the most annoying and the most deadly weapon we've got in our arsenal, KC2 TXO.
No. Well, at least the scanner works. That's the important thing.
Cool. Oh, very
Yeah,
nice.
I can hear. I can get YYZ arrivals and departures. I hear the traffic. It works great.
Very, very good. Good guys. So I can't wait for the detailed version, pictures and all.
Actually, speaking of that sort of thing, Dave, you were messing around with your computer up there, but you know what? What were you doing, or what did you accomplish with it? I didn't really get the story from that. I was concentrating so much on the probe.
Messing around with what computer?
Your Z80.
No, I wasn't messing around with it. It was working. I just Mark wanted me to. He wanted me to run one of his. He was reliving his glory Commodore days, and he was wanted to run some Commodore program on my Z80, which Commodore and Z80 is different. It had a terminal, and it could draw stuff on the terminal. Way back when the original CPM, it's a text based. It's not graphics. So my computer doesn't do graphics. It's just text based.
Okay. No, I was just curious because I had my head buried in that probe, and then I thought I'd be doing nothing but testing, measuring and all that kind of stuff. But unfortunately, or fortunately, depending on the way you look at it, Eric brought along a soldering iron. So when Dave said change that input capacitor, I couldn't say no. Well, I said I can't because I don't have a soldering iron. Eric has one. So we had to do a little bit of soldering, unsoldering, and soldering and unsoldering. And I don't know how many times Dave, you made me pull that thing in and out. Probably 3 times, I guess. Anyway.
Hey, but the fact was we had a soldering iron and we put it to use. That we got to say, at least we melted some solder.
Yeah. Well, it just shows, I really thought that we'll be able to characterize all this stuff. We won't have to do any blue collar work. It'll all be white collar work. And it turned out very quickly that we had to melt solder. Yeah. Anyway, it was good. It's good to get together like this.
And it was great seeing Marty at the Hamfest.
Yeah, that's right.
What a surprise.
What'd you buy, Marty?
Unfortunately, I bought one of those pressure-sensitive Morse code keys with the little wee parts. The first thing I tried to put on the board was a three-legged Q1, three-legged transistor, I guess. And I tried to move it. I got one leg down, but the other 2 legs were missing the pads. So I tried to shift it over, broke the one leg off. And then I put a probe on top of this thing to hold it still. And I flipped it. And I looked for the next hour all over for it. It's gone. It's the size of a grain of sand. So I decided instead of making an iambic paddle, I'd make a straight key and just use one. And I got the other transistor soldered on, but that's as far as I've got. So, they're tricky little guys, aren't they?
What transistor?
I don't have the number right here with me, but it's in the literature.
Put a posting on it. If I got any spares, I'll mail you some.
Okay, thanks. Anyway, that's what I got, and I got some adapters, and it was worthwhile going up, seeing you guys, and having fun. And my grandson, of course, lives in Ottawa, so we were there for the holiday weekend.
Before you go, Marty, did you see? Do you know Hugh VA3TO?
No.
Oh, okay. All right.
Hey, Marty, you want to buy a floppy disk? Want to buy a floppy disk? I got real cheap.
I actually have some discs to go into it, but I don't have
Ooh,
a floppy.
nice.
Yeah.
Real cheap. Anyway, Peter, I got a test for Frank. Frank, are you there? I see um, you're on the call on the thing. Are you there, Frank?
Yes, I am.
Okay, I got a test
There
for
you
you,
go.
Frank. Are you ready?
Okay.
Okay, let me start sharing my screen. I want to see if you recognize this
Oh
picture.
yeah, no, yeah.
Okay, let me find it. Where is it? Here. Can you see that, Frank?
Yeah, I can. Yes.
I took a whole bunch of pictures of this vintage equipment just for you, and we're going to show it at our presentation. But do you recognize this equipment?
Uh, Not specifically, no.
But
It's
but
near.
you're
It's the same vintage as I worked on, but it's not our. Oh, that's a Honeywell. Okay. Uh,
yeah, and
they were in the computer business. It was quite a few companies at that time. Oh, that one I knew. I've spent many an
this
hour in front of a Tektronix scope just like that.
then I've got a whole bunch. I don't know what are these computers there. I just took a whole bunch of. That's the Burroughs.
Yeah.
That's more Burroughs. And I don't know if this is. I don't know. That's a Honeywell, but it looks like some kind of drive.
I wonder if that drive
What's
works.
this Honeywell? DPS6. I don't know. It looks like some kind of a drive, like hard disk drives or floppies.
Yeah, that would be a floppy.
Yeah. So anyway, we went into the computer room at the Defense bunker, and they had all kind of old computer technology there, from PCs to all kinds of stuff. So I tried to take as many pictures as I can. So I just when I saw this stuff, I thought of you.
Yeah, I remember a lot of it well. Thank you very much.
Yeah, no problem.
Stop sharing.
There you go. Okay, I think. Oh, Michael's got his hand up.
I was just going to say, Peter bought a refill station, and Peter, I sent an email out talking about the settings on it.
Yeah.
And I'm sure that if you were to set it up for the highest fan speed sitting in front of you, you could make an SMD component hit the TV screen behind you. That I'm sure you could do it, Peter. No problem.
Well, maybe with the I got the small nozzle on it. Maybe I'll put the bigger one on. But anyway,
Just out of curiosity. Anyway, I think they're great. Those things, they're really good.
well, that heated up.
It's the same 878. What is it? The same one I've got, only it's a different manufacturer by the look of it.
Yeah, if you look on Amazon, you'll see that same format, same model number, but it's got a different company.
Yeah.
Yeah.
Anyway, okay. I just wanted to say that.
Well, I picked that particular company because it was not only was the cheapest, but it was free delivery, and the delivery was the next day.
Yeah, good stuff.
Mm.
Yeah, I use it, Michael. I use it to desolder, so I don't have to worry about a part. Like I don't have loose parts sitting on my board. Everything is soldered in, so I just crank it up to the highest because I want to desolder it quick. Because if you have it just puffing slow out, it takes a while to heat up the board. So I just crank it all the way up because all my parts are soldered in, and I'm just heating up that one part. So I don't blow parts across the board because I have no loose parts. They're all, as I said, I only use it to desolder.
I use mine to actually. I used I use it to make all the probe boards, and if you do it a couple of components at a time, close together, you can solder them in place as a group. But Hassan, when he was here, I forget how long ago, with who was it? Anyway, he and I and Eric was here. Yeah, I think Eric was here, and we were using the refill station at about around 200 degrees, and it took a long time to heat up the components. But at 300, it seems to be fine to put them in place. At least that's what I'm finding. For whatever that's worth, not much, but anyway.
Okay, just hang on a second. Hey, Eric, we're approaching the 1 hour mark. Do we have to stop and start?
Ken, do we have anything else we're going to cover tonight, or is this? Are we just having a chit chat for a while here?
I think we're going to be doing a chit chat. I actually have a question that I like
Sorry,
to see if
Ken, can you hear me?
Yeah.
Yeah, okay. No, we're good for now. Sometimes it lets you go longer. It seems to be more a file size than a time limit these days.
Oh, okay. Okay. Peter.
Yeah, I was just going to say one thing about Michael to be aware of is if the 200 degrees will eventually melt the solder, it's still not a good idea because it takes so long. If you look at the heat profile of some of these components, and some of these data sheets will show that, it'll show you the slow ramp and then all of a sudden peak at so I think you're better off at the higher setting and get it done. But I know Howard, he built the T41 by just putting a few SMD components on the board and then using his hot air gun, and that's how he did it. And he seemed to be successful doing it. I'll give it a shot at one of these days for soldering. First, I got to order some solder paste, but that's eventually the way I want to go anyway. Thanks, Ken.
Yeah. Anybody else? That's it. Okay, so we've actually come to the end of the agenda. I don't know what you guys want to do. I actually have a question, looking for some advice. So I don't know if you guys remember that that onion I made for a what do you call it? Random wire or non-resident antenna. Uh, Advice about where to mount the box. Should I mount it at the ground level? Should I mount it like, a certain height above ground? Can I actually place it high up with a what do you call it? Oh, what's that wire that sticks out?
Counterpoise, is that what you're thinking?
What's that?
Counterpoise?
Yeah, counterpoise. Yeah, couldn't think of the word. Because what I'd like to do is to have a uh, ugly ballon on it, so I don't bring current back in the house. So then I'd have to use a counterpoise on it. But if anybody has any experience, where should I be mounting this undone?
It should be mounted where your 50 ohm cable ends.
I can end it anywhere.
No, but where it ends at the antenna, where the impedance changes.
So I can have any length, but see what I'm planning to do. If you were to look in the top view, I'm going to have the antenna, the random wire in a C shape in the top plate, because I can't go in a straight line with it. But where to mount the actual undone? So should it be mounted near the ground, or should it be, say, mounted on the wall of the house a certain distance above ground? Or can I actually go up higher, say 10 feet, and start it there?
Ken, I've certainly done that, had it way up in the air.
What's that?
I've had it way up in the air, no issues.
Yeah.
You know, if the antenna starts up 15 feet above ground, I've had it up there. I'll put the ugly balun actually on the ground. So I'm running coax from the beginning of the antenna up in the air down to a big loop of stuff on the ground. I usually put a log over the top of it or something to hold it down flat. And that allows the outside of the coax to behave as a counterpoise for you down to where it hits the balun. It seems to work quite well for me, at least up to 100 watts. I've had no issues.
Okay. Oh, I don't know when I'll get around to. I could try a couple of different situations, but I'd like to get it up as high as possible.
Yeah, you have to bear in mind that the side of that box that the wire antenna hooks onto, that's where your antenna begins.
Yeah.
So if you put that way down by the ground, well, part of your antenna is now rising vertically or whatever to get up to the height that you're trying to get to, right?
Yeah.
And
So I
that will
could
change the radiation pattern.
so I could have it higher up on the house, and then have an ugly balun, like a piece of coax that goes down to the balun on the ground level, and then
Yes.
back into the house, and then a counterpoise.
Yep.
Yeah. What kind of counterpoise length would you recommend?
Um, Generally, what I've heard of is about a tenth of a wavelength at the lowest frequency you're using.
At the lowest frequency?
Yeah.
Okay.
So if you're down at 40 meters, sort of 4 meters would be a good
4 meters.
length.
You're looking at about 12, 15 feet.
Yeah.
Yeah. Okay. Cool. All right. Thank you for your advice. Does anybody have any questions or comments or anything they'd like to bring up?
Just a quickie one here. So if you're getting ready to get back on the air again, then Ken, maybe we should start. Maybe we should come up with a on-air events again, like we used to do at one time. But we can figure that out later. Yeah.
Yeah, I'd like to. Time is pretty tight right now, but eventually, and then I'm going. Usually at the end of July, I go uh, uh, up to Ellison, the park there. Well, we're not going this year. We're going out to up to Huntsville. There's Arrowhead Provincial Park, and I think the setup would be a lot better there than the one in Elliston. But I haven't decided if I'm going to take a radio with me or not. At that park, uh, there's potential bears, and everything's got to be locked up in the vehicle that has a scent on it. Your bathroom stuff, food, uh, barbecues, anything that would have a food scent on has to be locked up. So that could restrict on space of what I can take. Because normally what I do is when we went to Earl Row, we just stored everything in our big sleeping tent, and then I just stacked all my wood in the back of the truck. And anytime I needed wood, I just pull it out. But now we need the room to store everything in there now, so the wood's gonna have to be stored in our kitchen tent. But anyways, yeah, I haven't decided. Last time I took one up to Earl Row, I stuck to 20 meters because I already had a dipole made for it. So, yeah. Okay, Charlie, we'll see you later. So,
Hey Ken,
yeah,
if you got a bear coming into Arrowhead Provincial Park, you got big problems.
yeah,
Provincial parks are safe. Like I don't think you're going to get a bear in there because provincial parks, they got all kinds of people wandering the parks and stuff. I don't think you
the
have
last
anything to worry
apparently the last reported one was last June. So, and I
about.
think they said the year before there was one in August. So, I don't know. I've never camped in an area where it could be potential bears. So I'm not too worried about it.
I think I'll be more worried. And I'm 100% serious here. I'd be more worried about the chipmunks. I'm serious. Chipmunks will go and they will eat through your tent. If you have food in your tent, if you have a bag, they will go and they'll chew through it to get at the food.
Yeah.
I'd be more worried about chipmunks and raccoons than I would for bears. Seriously.
Yeah. Oh no. We've been going to Earl Row for like 10 years. Never had a problem until this last trip we did. The chipmunk that hangs around there started chewing through our food cooler. So,
for what it's worth, we were camping at Canis Bay, which is in Algonquin, roughly the same area as Arrowhead, I think. And we thought we came back to the campsite to find a small bear going through our fire pit. So that was a few years ago. I don't know how significant that is, but I've seen one once. So I don't know.
Yeah.
Algonquin Park for sure, because that's on. You got people. It's not patrolled, but in a provincial park, it's patrolled. You got the yogis. I call them yogis, whatever they're called. They go through the park and they check it. And provincial parks are pretty safe. You go up to Algonquin Park, you're in the wilderness, right?
Yeah. Yeah. Frank, got your hand up.
Yes. Just getting back to ham radio, I got a question. I've been playing around with FT8, and it's kind of new to me. Been very successful after sorting out the driver. But I got one problem.
You're muted, Frank.
Okay.
Still muted.
Just won't let me go. Okay. This is with regard to FT8, and I've made a couple of contacts, and everything's fine. But the one question I had was when you answer a CQ and you click on the station calling CQ, that my transmit goes active right away. And I could be in the middle of a time frame and I'm starting to transmit. Of course, that's useless. And after that, he doesn't come back because he didn't hear me. But as the cycles go, it transmits again. And quite often he'll pick up my other transmission. How do you turn that off? What I've read about it is you double click on that and it's supposed to wait until the next time frame and then send your answer to the CQ. But mine triggers right away. So if anybody in the group is familiar with FT8, and I'd like a comment on that. Anybody?
I've had the same problem, Frank, and I just suck it up and wait for the next turn.
That's what I've been doing.
You know, Frank, if I had this question a year ago, I probably could answer it because I was doing a lot of FT8, but I haven't done that for so long now. I can't remember. Sorry.
Oh. Well, I'm just new to it. It was a new mode to me, so I said, good, I got something new to learn, and I'll start playing around with it. But I'm quite pleased with it. The receive on it with my indoor antenna here is working very well. Of course, 10 meters is wide open now, so that's where the fun begins. Okay, thank you very much, and maybe I'll check Google again. I've got a lot of help from them before, but I'm sure it's just a little box somewhere that I have to click.
Yeah. Joe had his hand up.
Yeah, Frank, can you guys hear me, first of all?
Yeah.
Yeah.
I can hear you.
Yeah, Frank, what program are you using for FT8? Are you using the WSJTX program?
Yes, I am.
You are? Okay. Because I was doing quite a bit of FT8 last year, but I tend to use the SDR control app from like on the iPad, and that's pretty automatic. But I am charging up of my ICOM IC705 to do some more operating of FT8, and I'll be doing some testing with WSJTX. So you were saying that it's like there's a point at which it stops doing the back and forth, where it's like you've either got to initiate or it gets stuck. Is that what's happening?
No, it's just at the start of the sequence when I'm answering someone else's CQ.
Okay. I'll actually fire up the program and start testing it, and if I see anything similar, I'll get back to you.
Okay, thank you very much, Joe.
Yeah, no problem.
Frank, it's Michael, have you seen the FT8 operating guide by Gary Henson, ZL2 IFB? It's a very extensive operating guide. It's online.
Okay,
so if you just type in
IFB.
Yeah, if you just type in FT8 operating guide, it'll come up, and it's ZL2 IFB, Zulu Lima 2 India Frank Bravo.
Yep.
It's pretty good. It goes through all the how to set it up, how to set up the time stuff. And there's another program called Time Fudge that allows you to adjust your computer time to match the other guy, so the delta T, the times match. Anyway, that just for whatever that's worth to you.
Yeah, I played around with that one, and it works fine. Everything works fine except this one silly glitch. And I tried going into their online manual, and the darn thing's 300 and some odd pages, and I haven't got too deeply into it, but I can't find the answer in there. But I'll give that a try. ZL2 IBF. Thank you very much. I'll try that one, Mike.
ZL2 IFB, India.
IFB. Yep. Got it.
Okay.
Back to you, Ken.
Thank you. So does anybody else have anything to bring up or comment on, question to ask? Or... No, I think we're done then. So shall we call it a night, gentlemen?
I know.
Okay, guys. Thank you for joining in tonight. And the mixer is on June 4th. Yeah. So have a good night. Have a good rest of the weekend, and we'll see you later.
73.
All right.
73.
Thank
There you go.